Hey everybody, and welcome back. Okay, this is going to be about rational functions again, and we're going to go back kind of to the basics now of what is a rational function, how do you graph it, what's the parent function look like, how do we do the transformations, and writing the equation of rational function. So this is going to be more like what we saw with the other functions where we were doing the kind of the same steps each time. So looking at the graph, looking at the transformations, and then maybe we're going to dip back into domain and range again as well. Now you are going to use some of the ideas from the previous lesson, such as the asymptotes and just rewriting functions. We are going to dip into long division again as well. So make sure you have all of those parts fresh in your mind after today. So if you're like, I need to go back and review long division again, go back to the videos where we go through long division and get freshened up on that again. Essential questions: how do I rewrite a rational function to identify the transformations? So we're going to get a rational expression, and you're going to have to rewrite it in order to be able to tell what transformations are happening to the graph. So again, being able to do all this without using something like desmos to help you out. And then identifying the domain, range, and end behavior of a rational function. So last video we multiplied, we divided, and then we were making sure we were able to identify the excluded values from any of those products or quotients. So rational function on the right is a graph of what the parent function looks like, and the parent function is 1 over x. So you've got this kind of curved L-looking shape. Notice there's one on the top right, one on the bottom left. So when you think about the values of x, so when x is positive, the answer will be positive. When x is negative, you will get a negative y value. So that's why you see one above the line and one below it. We have that vertical asymptote at 0. So if x was equal to 0, it would be an undefined value. So that's why there is no value for x equals 0. It's just basically avoiding that. It's like that invisible force field. And we've also got that horizontal line that seems to be there. And that's the horizontal asymptote. We haven't really talked about that one yet. So the horizontal asymptote is the same as the k value, so the translation up or down. So if there's nothing there for k, the horizontal asymptote is at 0. Basically because there is no way for the answer to be 0 unless x was equal to infinity. So it's kind of the opposite side of it. X can't be 0 and it can't be infinity either. So no matter what we do to x, whatever value it is, you cannot get 1 over x to equal 0. In terms of transformations, there's two ways we're going to think about this. I want to show you the a and the b value. Normally we're ignoring the b one, but I want to put it in here just in case you did get asked about it. The one we're going to use most commonly is the one with the a, like our previous functions. So you have a, which is that vertical stretch or compression, times 1 over. So it's always going to be 1 over, or if there is a value in the numerator of that fraction, that is technically your a value. So 1 over x minus h, and then plus k. And notice that the k is outside of the parentheses. It's not part of the fraction. Just like all of our other ones, h is translations right left, and it's the opposite of what you think. That's why we have an x minus h. And then plus k is up or down for translations. And we just talked about that the k value is also the horizontal asymptote. Just one I want to point out to you. If you do 1 over x squared, you get this kind of funnel looking shape, particularly for the assignment that comes with this lesson today. You might have to use a rational function of 1 over x squared to complete the desmos activity if you choose to do that. So just keep that one in mind, that basically you can't have a negative solution. Remember, x squared, any number squared, positive or negative, the answer is positive. So that's why that L shape is kind of on top of the y-axis in both cases. So if you wanted it to be below the axis, you would have to make the a value negative. All right, so when we want to graph a rational function, say 1 over x, and we want to figure out excluded values, what happens to y near those excluded values, those are important things for us to think about. So we would say, all right, well, if I were to do the values of x into f of x, what would I get? So if I did 1 over x where x is equal to negative 100, I would have negative 1/100ths, which would be negative 0.01. If I did negative 2, 1 divided by negative 2, I have negative 0.5, negative 1, so I'd have negative 1, negative 0.01. So negative 0.01, I would have -1 divided by a tenth, so that would be 10, and it's negative, so I'd have minus 10. At 0.1, remember my excluded value is when x is equal to 0, so that's in the middle right here. So that would be my kind of undefined xfinity value. At 0.1, I'd have a positive 10, positive 1, 2, and then, sorry, a half, not 2. Or 0.5, and then 1 over 100, 0.01. So what do I notice? Like as I go to graph this, I would say as x is like out here at negative 100, I'm at negative 0.01, so I'm like really close to the axis. At negative 2, I'm at negative a half, negative 1, negative a half, I'm at negative, or negative 0.1, I'm at negative 10, so it's like coming straight down here. So I notice that like as I sketch this out, I'm getting that L shape. And that's what you're going to do. Like for a lot of these, you're going to have to test some values just to get an idea of general shape. And then same thing the other side. It's coming down, it's turning, it's going out this way. The reference points in these cases are when x is -1 and x is +1. So what do you get? And you get these 2 points that are closest to that kind of symmetrical point if we were going to think about it. So like the point symmetry here is actually not part of the graph at all. It's at 0, 0. If we had the x squared one, the x-axis or the vertical asymptote would be a line of symmetry. So there is symmetry in this. Sometimes it's point, sometimes it's line symmetry, depending on whichever function you're doing. So then the extremes of the graph, what essentially I want to know what is the end behavior. Like that's what I mean by the extremes of the graph. So what's happening as x goes towards infinity, what's happening as y goes towards infinity. We want to know the domain, range, and end behavior. So in this one, domain, we've got negative infinity. Now it's not negative infinity to positive infinity because there is an excluded value. So negative infinity to 0, that vertical asymptote, remember we're talking about x values, union 0 to positive infinity, and just nothing is included. So it's everything except, you could also write this as x is not equal to 0. That would also work for your domain. Range, it's also a horizontal asymptote of 0, so our range is going to look the exact same. Negative infinity to 0, union 0 to positive infinity, or y is not equal to 0. End behavior, as x goes towards positive infinity, y goes towards what? Remember, quick recap, we've got down the bottom and up top. So as x gets bigger, y keeps approaching 0. And we saw that with when x was 100. It keeps getting closer and closer to 0. So it went from 1 to a half to 1/100th. So it's approaching 0. As x goes towards negative infinity, y is also approaching 0. Now sometimes you will see 0 and then a little plus after it, and sometimes 0 minus. That just means that as we're thinking about x going towards positive infinity, it's approaching 0, but from the positive side of 0, so it's going through the positive numbers, versus as x goes towards negative infinity, we're approaching 0, but from the negative numbers. We're coming up from minus infinity. So sometimes you'll see that there, the positive, the negative. That's what it means if you see it. It can be written as an exponent, or sometimes it's down low. It just depends on who is writing the question. So if you see a positive or negative after it, that's what it means. All right, so if we are going to we're going to graph a rational expression, and Desmos is not an option for you. So like, I know, yes, you could graph it with Desmos or graphing calculator, but just in case it's not available to you, or you're going into a future version of math and you're like, okay, how do I do this? Really all we care about is the two asymptotes and the reference points. So where are those two reference points? And then just that you get that kind of general end behavior correct. So like what's going on as you approach the asymptotes? Are they going away from it? Are they getting closer to it? That sort of thing. So, and like where in relation to the asymptotes are they? So what quadrant are they in? So vertical asymptote, x is equal to h. So whatever the h value is, that's what your vertical asymptote is going to be. So that will be the value that would make the whole thing equal to 0. The horizontal asymptote is the k value. So it starts at 0 for the parent function, but if you move the whole thing up or down using k, then the vertical or the horizontal asymptote moves with it. The reference points. Now this is something that I would recommend you write down, you memorize. One of them is minus b times minus a, or sorry, minus b and minus a, and then it's minus b plus h minus a plus k. So your a and your b values coming from down here. A lot of times your b value is going to be just 1 because we're saying, okay, there's no b value. So it's just, you're imagining a 1 outside the parenthesis, and then you use your a value. The other reference point is positive b and positive a being added to h and k again. So in one of them, they're both negative, a and b are both negative, and the other, they're both positive, and that gets you your 2 reference points. Let's take a shot at this. You've got function given to us. A is 3. H is positive 1, because remember it's x minus h. K is 2, and we don't have a b value, but we could just say b is equal to 1. So vertical asymptote is the h value. That's positive 1. So x equals positive 1. Horizontal asymptote, y is equal to 2. So that's our k value. We've got minus b plus h minus a plus k. And then we've got b plus h, a plus k. So minus b, so minus 1 plus 1 is 0. And then minus 3 plus 2 is negative 1. The other one, 1 plus 1 is 2. And then 3 plus 2 is 5. So those would be my points. And then you might have to go and graph it. So you'd be like, all right, 1, 2, 1, 2, 3, 4, 5. So there's 1 point. Vertical asymptote is at 1. So you'd have your dash line. I know Desmos doesn't give you a dash line, but I'd like you to get in the habit of putting it in. Y equals 2 is the other one. And you got 0, negative 1 is that other reference point. So you know kind of the quadrants that they're going to be in, and you could test if you wanted just to see, like, are you on the right track? But you know the general shape, and there wasn't any indication that we were going to have stretches or compressions. So we know that, sorry, reflections, not stretch, compression. We do have a stretch. We have a vertical stretch of 3. So it's going to be a little bit steeper than you saw in the parent function. But unless it's asking you for more than 1 point, usually the reference point is enough. Sometimes you might just test a couple of values near the asymptotes. You might say, okay, let's test when x is maybe, let's see, so the vertical asymptote is 1. So let's test when x is 2 and 0 to see where the points are. Maybe let's do 3 and minus 1 as well, just to get that general gist of it. And then maybe 1 point that's really close to it as well. All right, your turn. So without using Desmos or graphing calculator, I want you to try and identify the vertical and the horizontal asymptotes, and then also the 2 reference points. So refer back to that slide with the formulas if needed, but you should have all the information you need given to you in the question. Try not to use Desmos, except maybe to check your work afterwards. Pause the video, then come back and see how you did. All right, so we've got a minus a value. That means there's a reflection as well. We've got h is negative 1, k is negative 3. So vertical asymptote is at x equals negative 1. Horizontal asymptote, k is equal to minus 3, so that's going to be our y value. The reference point, so we've got minus b plus h minus a plus k. So minus b is negative 1, h is negative 1, so we're going to have minus 2. And then minus negative a half is just a half, so 0.5 minus 3, so we've got minus 2.5. So there's 1 point. And then the other one, b plus h, so that'll be 1, minus 1 is 0. And a plus k will be negative a half minus 3, so minus 2.5. Or minus 3.5, I'm sorry. All right, so there's my 2 reference points. For the other one, we've got a b value of negative a half as opposed to an a value. So let's see, that would be a vertical asymptote of 2. So h value is 2. Horizontal asymptote of 1. So y equals 1. Reference point minus b, and b is 0.5. Actually, that's 1 over b. So 1 over b is equal to negative 0.5. We want to solve for b. So b is equal to 1 divided by negative 0.5. So 1 divided by half is 2. So b is minus 2. So that's an important one. This is, remember, 1 over b, not the b value if it's down here. So b is minus 2. So that'll be 2 plus h, which is 2. So that'll be 4. And then minus a. So a is 1 in this case. There's nothing out here, so it's just 1. So minus 1 plus k is just 0. And then we've got regular b, so minus 2 plus h, which is 2, so it's 0. And then we've got 1 plus 1 is 2. So there's my 2 reference points. All right, now this is probably the majority of what you're going to need to do for this lesson, is rewriting rational functions to be able to tell you what are the transformations. It doesn't have like a specific name like standard form, general form, or anything like that. We're going to do long division to rewrite it as a quotient and remainder. So maybe you could call it quotient remainder form if you need a name for it. So at the moment, it's a rational expression. You've got one polynomial divided by another. It doesn't really give us a lot of information. We can tell that the vertical asymptote is still at 1. So that's that value that would make the denominator 0. But beyond that, it doesn't really give us a lot of information. So we're going to actually do the long division here. And I'll show you what this looks like in a second. We'll actually see it resembles exactly what we're looking for. So we got x minus 1 divided into 3x minus 4. X goes into 3x 3 times. So we get 3x minus 3. Change the signs. We get minus and plus. And that would be minus 1 is my remainder. And we're done. So this would end up being 3 minus 1 over x minus 1 if we do it in that quotient plus remainder over divisor still. And that's what we're looking for. So g of x is equal to 3 minus 1 over x minus 1. Now if we switch these places, we get minus 1 over x minus 1 plus 3. Now it looks exactly like what we were just dealing with. So a value is minus 1, h is 1, k is 3. And that's really what we were looking for, is that k value, and then also just to make sure we had the right a value as well. So we've got vertical asymptote at x equals 1, horizontal at y equals 3, reference point 1. We've got minus b, so minus 1 plus h, which is 1. So minus 1 plus 1 is 0. And then minus a, so that'll be minus negative 1. So positive 1 plus 3 is 4. And then reference point 2, we've got b, which is 1, plus the other one is 2. That was my h value. And then minus a, or sorry, a, so that's minus 1 plus 3 is 2. So there's my 2 reference points. Domain, everything except for the asymptote, so at x equals 1. So minus infinity to 1, union 1 to positive infinity. Range is everything except for the horizontal asymptote. So we got minus infinity to 3 and 3 to positive infinity. Sorry, I didn't leave enough space for myself in this. End behavior. As x goes towards infinity, y goes towards, and then as x goes towards negative infinity, y goes towards blank. So for this one, a couple things you can do. So like we've got our reference points. So I've got my graph, vertical asymptote at x equals 1, horizontal asymptote at y equals 3. And then we've got the reference points of 0, 4. So this is 3, so 0, 4 is up here. And then 2, 2. So now we can see, all right, there's the quadrants that it's in. So my shape will have that L shape and approaching those two asymptotes, but never touching them. And this is one you can obviously check with Desmos. There's no rule against checking it or your graphing calculator. But because we had that -1, that a value, it doesn't look like the traditional rational function. It has actually flipped over the horizontal axis, or the horizontal asymptote in this case, which is why the functions are in the opposite quadrant. So that reflection was in there. So as x goes towards positive infinity, y goes towards 0 again, but this time from the negative side. And then as x goes towards negative infinity, y goes towards 0. Actually, I'm sorry, it's not going towards 0. What's it going towards? So the horizontal asymptote is at 3, so it goes to 3 and approaching from the negative side, so that's what that 3 negative would mean, and 3 positive. All right, let's try another one. So our long division, -2x plus 4, going into 4x minus 7. So -2 goes into 4 minus 2 times. So we get -4x minus 8. Change the signs. -7 plus 8 is 1. So we get a quotient of -2 plus 1 over -2x plus 4. All right, so good so far. We've got g of x equals 1 over. Now notice with my divisor that -2 could be factored out of this to leave me with x minus 2. That's what we need to do here because that's actually our b value. So we got -2 x minus 2. So I'm factoring it out to get x on its own because remember our formula is x minus h, not bx minus h. So it has to be outside the parenthesis. All right, so then that means 1 over b is equal to -2. B is equal to -1/2. So if I need that b value, there it is. And then -2. All right, so vertical asymptote. This is a mistake a lot of people would make as well. Vertical asymptote is at 2. Horizontal asymptote is at -2. Reference point 1. So we've got -b, so that'll be 1/2 plus h, which is 2. 1/2 plus 2 is 2.5, or 5 over 2. So 2.5 or 5 over 2, doesn't matter. Reference point 2, other side. So we got a value. So it's one of those ones where the -2 could make the whole fraction negative. So you could say the a value is -1 and the b value is +1/2. It doesn't really matter here. We're going to get the same answer just from the way it sets up. So we're going to just let the a value stay as 1. So a value -1, -2 is -3. So then we got -1/2 plus 2 is 1.5. So that's 3 over 2. And 1 minus 2 is -1. All right, so there's my 2 reference points. My domain, everything except for the vertical asymptote. So we've got, I'm going to go with x is not equal to 2 in this case. Range, y is not equal to -2. And end behavior as x goes towards positive infinity, y goes towards what? As x goes towards negative infinity, y goes towards what? So a negative b value should reflect it over the y-axis, so I am expecting it to look like this again. So reflecting over from its original position. And then b value, so we've got a horizontal compression of 1/2. So it's going to change it a little bit, but my reference points are at, let's see, so we've got vertical asymptote at, erase this quick. Vertical asymptote at 2, horizontal asymptote at -2. Five over 2 minus 3, so it's down here, and 3 over 2 minus 1 is up here. So yeah, there's my function. And all you need is a rough graph like that just to kind of picture it. So as x goes towards positive infinity, y approaches -2 from the negative side. As y approaches, or as x approaches negative infinity, y approaches -2, but from the positive side. All right, your turn. You only got one example to do on your own, so pause the video, take a shot at it, make sure you've got the asymptotes, the 2 reference points, the domain, the range, and the end behavior, so everything into one. Pause the video, come back, let's see how you did. All right, so we got x plus 2 into 3x plus 8, so this is going to be a 3. So that means we've got 3x plus 6, subtract, subtract, we get 2 as the remainder, so we're going to have 2 over x plus 2 plus 3, so that means my a value is 2. Now you can leave it up on top of the fraction like that, or what I like to do is just erase it or cross it out, move it to the a spot so I can see clearly where it is, and put that 1 back where it belongs. So you're just factoring out the 2. All right, so then horizontal asymptote is that x equals -2. The vertical one is that y equals 3. Reference point 1, minus b plus h, so there's no b value, so it's -1 plus negative, or -1 plus -2, so that's -3. And then a, so -2 plus 3 is 1. Reference point 2, b value is 1, -2 is -1, and then 2 plus 3 is 5. So just a quick sketch of what I'm expecting here. -2 for the vertical, 3 for the horizontal. Got a reference point at -3, 1. And then I've got another one at -1, 5. All right, so it's going to come down and around. All right, so domain, x is not equal to -2. Range, y is not equal to 3. And end behavior, x goes towards positive infinity, y goes towards 3 from the positive side. X goes towards -infinity, y goes towards 3 from the negative side. How'd you guys do with that? All right, final part for today, writing the equation of a rational function from a graph. So we've done this before with different functions. It's just a case of what information do you need and how does it fit in. So our h value, remember those are, h and k are based off the asymptotes. So the h value is the vertical asymptote. So looking at the diagram here, that's at 3, it's the vertical green line. Sometimes you give them the line, sometimes you're not. So I'm just going to give it to you to get started. But remember, if you get one without it, you're going to have to see, okay, where is that excluded value and then write it in. So h is 3. The k value is 2, 4. So 4. And then x and y, pick any point on the graph. The 2 reference points are typically the ones to work from. So I'm going to go with 2, 2. And then we're going to sub everything in, and we're either going to solve for a, or you'll be asked to do the 1 over b. So you'll solve for 1 over b, and then tell us what the b value is. A is typically what you'll get asked for. So y value 2 is equal to a times 1 over x is 2 minus h plus k. And now you just solve it like a normal equation. So 2 equals a over 1 minus 1 is negative 1. Plus 4, subtract the 4 from both sides. Minus 2 is equal to minus a, which means positive 2 is equal to a. So we would say f of x is equal to 2 times 1 over x minus 3 plus 4. That's it. So, I mean, you guys have done that before. It shouldn't be too crazy. Make sure you got the new information down and what you need, and then you're going to try one on your own in a second. All right, there is your graph. Write the equation, again, in the form of y equals a times 1 over x minus h plus k. So have the a outside of the parenthesis. If this was a test or quiz, I might ask you, what is the a, h, and k value for this equation? All right, so our h value, our k value, our x and y, so we'll just pick one reference point. H is minus 3, k is minus 1. Reference point, I'm going to go with minus 5, 0. Typically, one of them has a 0 in it. It's a nice one to work off of. It just means a little bit less work sometimes. So we got 0 is equal to a times 1 over x is minus 5 minus negative 3, so it's plus 3, all over, and then minus 1. So 0 is equal to a times 1 over minus 5 plus 3 is minus 2. So it's minus a half minus 1. Add 1 to both sides. 1 is equal to minus a half a. So to get rid of that, we're going to multiply by minus 2 over 1. So the 2's cancel, the 1's cancel, and the negatives cancel out. So we're going to get minus 2 is equal to a. And looking at the shape of the graph, like it's up in the top left and bottom right, it does indicate a reflection should have happened. So I was expecting a negative a value. So f of x is equal to minus 2, parenthesis 1 over x minus h, so plus 3, and then minus 1. All done. Okay, so for today, you had to rewrite the rational functions to identify transformation. So that's, you do the long division. You write it as remainder over divisor plus the quotient. So you just flip that order to give you that kind of same reference that you want, where you've got the a, the h, the k all in the recognizable positions. And then how to identify domain and range? Well, the domain is everything except for the vertical asymptote. The range is everything except for the horizontal. And then for end behavior, you notice that in both cases, or in all cases, it was approaching the horizontal asymptote, but from the positive or the negative side. Graphing it and then just having a quick look to see where it is the best way to figure that out. After today, so you've got that one folder, graphs of rational functions. The independent practice, you have the option between textbook work or Desmos. I do recommend the Desmos. It's a little bit more experimentation and figuring out what the graphs look like. But if you want to do the textbook work, that's totally fine too. This is a shorter week, so have a great Thanksgiving if I don't hear from you before then, and I will see you back next week.